Now this is a true dual port RAM. So you have two ports, port A and port B, both capable of reading and writing. And so that is why it is called true dual port RAM. So let's look at it. So you have two outputs, QA and QB, one for each port, port A and port B. You have two data inputs, one for each port again, and two address buses, one for each port again, and two write enables. Here we've used a single clock. We can also choose to use a dual clock, but that just makes the design that much complex. But since we have a dual port, we can have one clock and synchronize both the reads and writes from both the ports. So you have the RAM definition. It's a 8-bit 64 location RAM. Then you have the port A, and port B is similar to port A. And so in port A, you have a clock, and at the clock edge, you check for write enable. If write enable is 1, then you take the data, write it inside. At the same time, you fetch an output using the new data. Now this is like a bypass, right? So it's something like this. So you have your memory. So this is your memory, and you have Q output. You have this data that is coming in, and this data is given to your Q based on a condition, that is your write enable. So if your write enable is 1, so if your write enable is 1, then your data is given directly. If your write enable is 0, then your Q is fetched from your memory. So it is like a bypass, right? So this statement is like a bypass to get new data. So the data that is currently being written into the memory is kind of bypassed and given to Q also, right? So that is the only way we can get a new data, right? Okay, so if you're writing, you do this. If you're not writing, so there is an else condition. So you can do either or, right? So this is both. This condition is write and read, and this condition is only read. So in the read case, you give the address, the port A address, and you fetch the data, right? So a similar thing is happening in port B also. So this is your write block, and you can also do an optional read, and this is your exclusive read block. So if your write enable is 0, then you do a read, and if your write enable is 1, then you do a write and an optional read also. So your memory is capable of doing, say, if we take this case, say write enable is equal to 1, then you can possibly do 2 writes and 2 reads, or 2 writes and 1 read, or 2 writes and 0 read. Now this is the case if both the write enables are 1. Now if only one of your write enable is 1, say only one write enable is 1, then you can do one write and optional one read, or simply just one write and 0 reads. Now if both your write enables are 0, then we can have 2 reads and 0 write, or 1 read and 0 write, or even 0 reads and 0 write. So read is always optional, and the processor can choose to read or choose to ignore one of them or choose to ignore both of them. Right? So if write enable is 0 in only one of the blocks, then we are into this case where we have one write and one read, or one write and 0 read.